So I'm going to take a little bit of time today just to talk to you about one of our newer projects that we have in the Movement Science Lab that is looking specifically focusing on youth long-distance runners. So when we look at common injuries in youth long-distance runners, there was a study in 2022, so very recent, that had just over 1,900 runners in their study. And what they did was they just monitored their injuries that occurred during a season. So it was basically for 28 weeks. You can see our breakdown of high school and middle school was about 2/3 high school in this group and 1/3 middle school. And 18% of the runners reported that they did experience an injury at some point during their season, with a total of 583 unique injuries being reported. So let's look at the breakdown of these injuries specifically. We can see we have about 4 main categories. Number one, the knee being at 33%, lower leg at 19%, foot at 14%, and ankle at 13%. So if we look at these 4 categories, we see that they can all be grouped together and kind of considered as lower extremity injuries. Right, so if we look at them, the lower extremity injuries can account for 79% of all injuries that were experienced by these youth long-distance runners, for this cohort specifically. So our medical team here at Scottish Rite, led by Dr. Miller, was really interested in looking at these lower extremity injuries that we see in runners, and if we could identify any movement patterns that we may see in those kids that were injured versus the kids that weren't injured, to see if there was any differences in their strike pattern or in their force distribution or in their running mechanics. So we're currently targeting healthy high school and middle school long distance runners. We have tested some college runners as well, I would say too, so we wouldn't turn them away. And we're bringing them into the lab, and this is the data that we're collecting on them. So kind of like Sophia just mentioned with the athlete profile, we're trying to get a good profile of these runners, looking at more than just movement, more than just force distribution through their feet. But we're collecting questionnaires, so like injury history, what have they been injured in the past, what's their training regimen, how often do they run per week, how many miles are they running per week, what shoes do they train with, because there's different types of shoes. And then diving more into those same questionnaires that are involved with the athlete profile, so looking at like athletic identity, sports specialization. And last but not least, we are collecting injury surveillance as well. So in a year after they've been tested, we'll text them all back and see if they've been injured in the last year, which will allow us to then kind of create, when we have a large cohort of data, create 2 separate cohorts, those kids that got injured within a year and those kids that didn't get injured, kind of analyze the differences in their mechanics between those 2 groups. Another thing we're collecting just while they're running is just heart rate data, as well as anthropometrics and range of motion, so looking at like what their hip flexibility is, their ankle flexibility, just trying to see if we see any contractures or anything that may be inhibiting some of their movement patterns while they're running. We also measure their strength on our Bioengineer machine, where we just look at peak torque values for hip flexion extension, hip ab and adduction, and ankle dorsiflexion and plantar flexion as well. And then lastly, while they're doing their, we do a 5-mile run with them. And so the goal of the 5-mile run is to get them fatigued, right? So as they get to mile 3 or 4 or 5, we want to see if we see any changes in their mechanics, changes in their pattern, because they're getting more tired and more fatigued. So during their 5-mile run, we have them wear these plantar pressure insoles that are made by Novell. And as you can see in the diagram here, it breaks the foot up into 3 different sections. We have a hind foot, a midfoot, and a forefoot. And these insoles measure the force that is being applied by the foot onto the ground during each stride of their 5-mile run. So we end up with a lot of data, a lot of strides. And they just wear these in their shoes, just right underneath their feet, so that we're able to measure the force that they're applying on the ground as close as possible. And lastly, we are also measuring, doing motion capture through their 5-mile run. So we put markers on them. So like Sophia just showed you guys, as we can then calculate their kinematics and their kinetics. So a lot of times with youth running, or not even just youth running, but running motion capture studies, they're most of the time have to be done on a treadmill, because like Sophia had mentioned, there's limitations with a lot of labs across the country, right? And so some places have the ability to not do a treadmill, but a lot of times it'll be just done by moving a treadmill into the center of your motion capture lab, and they just run on the treadmill for X amount of miles, and you capture their movement patterns while they're doing the running. Those treadmills can sometimes be instrumented with force plates in them, so you can sometimes still get kinetics with those studies, but we all know that when you run on a treadmill, your mechanics change, right? It's not your normal surface that you're running on. So for us, we wanted to mimic their training surface that they're used to, or their running surface that they're used to. And so since we have such a nice, wonderful lab that's really big, we're able to open up our sliding doors here that you can see. And so our study starts by these patients running through those doors directly into our lab, and they then run across the force plates, as you can see here in the bottom left, which will allow us to collect the kinetics and kinematics as they're running through the lab. They then leave the lab and go on a half-mile loop, kind of through the sidewalk, through the parking lot area, before they return back onto the track and come back into the lab. So every half mile, they run back through the lab, and we do it for about a 5-mile run, right? So we end up with about 10 to 12 laps in through the lab. So we collect this data on our kinematic and kinetic data on them at every half mile, and we're able to analyze that on the back end, which we will get into in just a second. So I want to show you some of the data that we have from one of our runners that we've collected. Now, this runner, when they were tested, was a high school senior that had accepted an offer to a D1 cross-country program. So that's who we're going to look at today. What's plotted here is our total force, looking at those insoles in the shoe on the left side. Now, when we look at it like this, there's a lot. There's a lot of strides. This is across the entire run. There's not much that we can see here, but I wanted to show one thing that we can kind of look at when we look at the kind of the broad graph here. When we plot the right side, we can see that this runner is loading their left side significantly across the entirety of the run. But let's look at it a little closely, and let's zoom in on specifically just 5 strides so we can look at this in a little bit more detail. So here's our total force plotted on the left, just like we had on the last graph, and we'll throw on our right side here. So again, we kind of see that the right force is a little bit less than the left force, right? But if you remember, we're able to break these up into 3 different regions of the foot. So total force is valuable. It can help us to look at just total force of the foot and when you compare it between the left and right sides. But we want to break this down into these 3 regions and get a little bit more detail as to where maybe more force is occurring or less force is occurring between their left and right sides. So let's start with our left hindfoot force. So that's what we have graphed here. We'll add in our left midfoot force, and we'll lastly add in our left forefoot force. And when we plot the right side against it, we start to see some differences. So if you look at the darkest graph of the blue and the red sides, we'll see that our hindfoot force is significantly different between the left and right sides, with the right showing more force in the hindfoot than the left. Moving to the midfoot, not too much different, slightly higher on the right side, I'd say, but when we move to the forefoot, then we see another drastic difference. We see the push-off power on the left side is significantly higher than on the right side. So this is just kind of an example of what the data can look like when we're looking at this force distribution through the foot. Now, this is just 5 strides through the entire run, but we break the run up into miles 1, 2, 3, 4, and 5, and we're able to kind of average this force distribution that occurs within each mile and see if, as they're getting fatigued and getting more tired, does the force distribution change? Is their push-off power changing? Is their heel strike, are they still heel striking, or are they more of a midfoot striker as they're changing through the run? So that's just some of the stuff we're able to look at with our plantar pressure data. When we move to the kinematics, what we got plotted here is just sagittal and coronal trunk as well as sagittal hip and knee. And we have 6 lines on the graph. We have mile 0 through mile 5. So at each mile, we plot their data. And what we're really looking for on the kinematics here is what their joint variability is. Now, that's a term that we use just to kind of see how repetitive someone's motion is, right? So if they're not as repetitive and there's a bigger gap between your lines that you have plotted on the graph here, you're going to have increased variability. And sometimes too much variability can lead to an injury risk. So that is what we're going to assess looking at the kinematics here. Taking it another step further, these are all plotted across like one running cycle. You can see the x-axis here is from 0 to 100% of one running cycle. If we plot it a little bit differently and we look at how one joint is related to another joint, we can look at what we call joint coordination. So here we have our sagittal knee angle plotted on our y-axis and our sagittal hip angle plotted on our x-axis. So we're able to determine, as their hip is flexing or extending, what is their knee doing? Is their knee flexing? Is their knee extending? So we're able to look at the pattern that they're choosing to use while they're running through the hip and the knee across all of these 6 graphs, which end up being the 5 miles. And again, with this joint coordination graph, we're able to also look at the variability in it as well. So looking at how repetitive this joint coordination is through the entirety of their run. So we have a colleague that we work with that says that prevention of injury is impossible if you are unaware of what your injury risks may be. So how can we then help these runners become a little bit more aware of what injury risks they may have? We create a report. So a lot of this data that I just presented to you is given to them, where they can look at their range of motion, asymmetries between the left and right side, just to see if there's some differences there. We also give them the strength to see if they have any deficiencies between the left or right side. Also looking at spatial temporal parameters. So what's their float time, or their stance time, or their swing time, or their running speed? Does it change from mile 1 to mile 5? Or also their stride length. Do they have larger strides at the beginning when they're less tired, and as they become more fatigued, do we see differences, right? And then the cool graphs here are at the bottom are also just that force distribution through the insoles that I presented to you guys earlier. So they're able to get this data, they can take it to a coach, they can take it to an athletic trainer or a strength and conditioning coach, and sit down with them and kind of analyze it and see if there's any areas of weakness that they may need to kind of work on, just to kind of try to decrease their chance of an injury as much as possible. So how in the long term does this help injury prevention? Well, our long-term goal, like I mentioned at the very beginning, was looking at injury surveillance, right? So we're going to ask all these runners if they've gotten injured in the last year, which will allow us to kind of take 2 different groups and create our runners that have been injured, or runners that have not been injured, and then analyze if we see any different movement patterns between those 2 groups, and to try and predict what mechanics might lead to an injury risk. Thank you guys. I appreciate the time this morning.